Hello, my name is Alkhudair, a PhD candidate from University of British Columbia, Canada. I would like to talk about our research that entitled LIMBKIT, a portable 3D printing kit for prosthetic sockets. First of all, accessing affordable and functional prosthetic sockets in rural and remote areas is a significant issue due to the lack of health services or difficulties in accessing them. For example, First Nations population in Canada face numerous challenges when seeking prosthetic service. According to WEES in 2023 and SHADE in 2024, individuals living on reserves often encounter long travel distances and inadequate transportation reimbursements, which further complicates their ability to obtain necessary care. The gap was there is currently no known method or evidence on how to provide service in these situations. 3D printing is gaining interest as a potential application. Operation Namaste, a nonprofit organization, developed a LIMBKIT project which consists of a portable station that includes 3D printer and other components that are relevant to the BNO to provide on-site production. It has not been tested yet to compare the 3D printed sockets via LIMBKIT with the definitive sockets. So, in this study, we hypothesized that mobility and other relevant functional outcomes will show minimal differences between the 3D printed and definitive prosthetic sockets. The novelty of this study is a single subject design, which each participant is their own control. Also, the entire data collection has been conducted remotely. Each participant wore their definitive prosthesis before transitioning to their customized 3D printed prosthesis. We took 9 data points for each phase. We monitored their performance using multiple outcome measures, such as timed up and go, figure of 8 walk test, 4 square step test, short physical performance battery. Additionally, we require them to complete several questionnaires to assess critical factors such as comfort of the 3D printed sockets. We took those questions from the well-known outcome measures such as socket comfort score, activity-specific balance confidence scale, and prosthetic evaluation questionnaire, specifically the part of the mobility. We successfully recruited 8 participants from Metro Vancouver, British Columbia, Canada. The participants included 6 men and 2 women, aged from 48 to 71 years. After applying the 2 standard deviation band method, we found that the 3D printed sockets didn't impact mobility performance, balance, or self-reported balance, confidence, or self-reported mobility. There was no significant performance difference between the 3D printed and traditional sockets. However, it was important to note that some users experienced reduced comfort, indicating that enhancements are needed in this area. Those samples here for the visual graphs of a single patient in 2 outcome measures, the timed up and go and the socket comfort square. The remaining graphs, you can access them via the QR code here in the right bottom corner. Overall, the findings are encouraging regarding the feasibility of the LIMBKIT. So it could be a solution for areas where access to prosthetic care is often limited. Also, further research is needed in a socket's comfort and kitting. Thank you.